Hello and welcome to this video on designing test workloads with NoSQLBench. My name is David Joy and I'm a data architect with DataStax. In this video, we're not going to talk about NoSQLBench setup, but we're specifically going to focus on how to design the test workloads. So let's start with level ones, that is the essentials of NoSQLBench. So if you've already used NoSQLBench or have set it up, there are key things that you need to know. One is uh, data gets generated through this capability called virtual data set. So NoSQLBench actually uses that capability, which is embedded in it to generate data on the fly. And it's all of that, everything that we execute with NoSQLBench is basically through command line. We will have to understand this fundamental idea of cycles. A cycle is basically every statement that gets executed. There are various types of drivers available. There is the standard out driver, which allows you to just output the statements that you're generating, versus the SQL driver that allows you to run these statements on, Cassandra. Through the SQL driver, and then we have all this matrix that gets generated from NoSQL bench that goes into Prometheus and Grafana. And the most important thing that we need to do is make sure that we understand bindings when we generate our workloads, because these bindings really generate the data that we want to specifically generate. So if you have installed NoSQL bench, you can just go do dot slash nb hyphen list drivers, and it should give you a list of drivers that are available with NoSQL bench. You can also do dot nb help and just specifically put the driver that you want to see and get instructions around it through that. So when you typically run a workload, this is how you will have to write your command lines. You'll have to do dot slash nb. You will have to put start or run, and then put driver, the kind of driver that you're using, put the workload, and the workload should be equal to a specific YAML file that you generate that has all the workload specifications. And then you will tell how many such statements do you want to run. So how many cycles you really want to run. Do you want to run it 10 times? Do you want to run it 50 times, 100, a million? Like that, it can go on. So in these two statements that you see here, we are using driver equal to SQL. So it's basically going to run this on Cassandra, while the std out driver in this statement is going to just generate the output. So, and it's used specifically for testing purposes, to test if you're generating the right sort of data. All right, so let's talk about designing workload. So any workload that you're designing in NoSQL bench will be a YAML file, and a YAML file should have blocks, statements, tags, bindings, and parameters. Now we'll go deeper into these fundamental ideas, but the main thing that you need to understand is a block is basically an overarching container that runs different statements. Each statement is basically what kind of an activity you want to run, what you want to generate, and a tag is a typical name that is associated with a statement. And binding, as we were speaking previously, is the function that actually generates the data. And there are parameters that you want to associate with different statements, like ratios or consistency levels, that you can define using parameters. And there is also capability to do multi docs. All right, so here's an example of a test YAML that we're going to run. The name of the doc is doc1. There are two blocks, the block one and block two. Each one of them has different statements. So, but if you notice here, I have statements with the same name, S1 in both of them, but they're understood to be part of different blocks. So there will not be an issue. We have bindings defined called alpha and beta, and the alpha here will generate uniform from 1 to 50, any number. Beta will generate numbers from 51 to 100. These are just functions that we are calling in our statements. And again, they should generate that number. Again, you have another alpha binding that is defined here, but if you can see here, the binding is a combination, so it will generate a combination string. So if you notice here, the thing is you can have one binding written for all the statements of your block. You can also have that for the overall document. You can generate a binding like that. You can also write bindings very specifically for a particular statement. And so that ways you have all the flexibility that you need. So let's just go back and just run the statement. I'm going to run and generate 10 cycles of, and I'm using the std out driver to generate and see how this data looks like. So again, we saw block one, block two generated a combination. If you see block one statement two generated a different number. Again, That ways you can see that the data is getting generated. If we do the same thing again, because NoSQL bench is deterministic, it should generate the same data actually. So if you see here, even when I ran it for the second time, it actually generated the same data. So that is one advantage that we have with NoSQL bench. So let's go back to this YAML again, and now we are defining, parameter. So what we're doing here is we have two blocks, block one and block two. I want to generate more of block two data. So ratio of 8 and the ratio of 2 for block one. So let's just do this. And this way you will see that block two data will be generated more because of the way we have designed and defined the parameter. You should see data. So again, as you see, block two got generated more, right? So that's the advantage that we have here. We can define things the way we want it, change your cycles, and get the data. All right, so let's talk about level two. And this one will specifically focus on using the SQL driver. So the main thing that you need to understand is that each of these statements that you use with the SQL driver need a specific phase. And there are multiple phases. We have a phase for generating the schema, for creating the schema. Basically, that phase is called schema. And then we have a ramp up phase. The ramp up phase basically creates your data, and it's mostly insert. So if you want to just to write, you want to use phase equal to ramp up. And a main phase is basically where you generate a mixed read and write pattern, where you want to have 50% read and at the same time 50% writes going on. So very similar to what kind of your production workload should look like. So that phase would be called main. So you want to split your YAML file and different phases. And so let's have a look at how level two YAML would look like and how we can design it. All right, so we have this NoSQL bench level 2 YAML. Let's go into that. Again, what you would notice is we have one doc, two blocks, block called schema, and a block called ramp up. The schema block has a tag with a phase called schema defined, which is for generating the statements for creating key space and creating table. We have a ramp up block with the phase equal to ramp up, and that is mostly for inserts. And what you would notice here is we are doing insert into this table, key and a value, and it identifies two bindings, row key and row value. Again, there are two significant things that you want to notice here. We have defined row key one at a block level, and we have binding at a statement level for row value. It will generate some random names actually. And insert two has the same thing happening, but if you notice, a row key here is defined specifically for insert two, and it will generate only numbers from 1 to 50, whereas row value will generate first names for that particular statement. So we are again making it flexible. You can define things at a block level, and that runs for or that runs all the bindings for all the statements at the block level, or it can be specific to a statement. So let's go and run a few statements. What we will do here is we are going to basically run and see how the output looks like. So we'll run the schema phase and see what it's getting generated through NoSQL Bench, and see if you can notice is that it'll generate statements that we defined earlier. So create key space and create table. And now let's see what an insert statement would do. So we will have to do ramp up, and we'll have to associate that with a certain set of cycles that we want to run. And again, we're running 100 cycles, so it's going to generate different insert statements that will go to SQL. And that's what is happening. If you see, notice here, different numbers are getting generated. Again, if you notice it, there are some points where the number is actually less than 50. That's because of the specific binding that we define for insert to. All right, so now that we have focused on how to write a YAML file with SQL Driver and how it actually works, let's focus on running the main workload. And the key idea about the main workload is that the main workload should be similar to what your actual test phase is, or should try to emulate your production environment. So what we need to do here is, have the right ratios decided and have the right parameters defined for your main workload. Again, the key thing to know is, like, if you're running the main workload, you want to start it, you want to define the driver, you want to tell what workload you're running. It's just NoSQL level 3 that we'll run. We're telling that we want to run the main phase, so we'll put tags equal to main, phase equal to main. We'll do cycles equal to 100k. That's what we want to run. and we're doing threads equal to auto, basically use as many threads that we have available. And then we're defining the set of host where or nodes basically in my Cassandra cluster or my data center, and I'm basically reporting that to go to my Prometheus or Grafana. So that's what we will be doing in the next example, and let's have a look at that. All right, so we have this third YAML that I've written here that's specifically to focus on the main phase, and we're calling it NoSQL Bench Level 3 YAML. So let's just go into it. Basically, the first part is the same that we saw in our previous example in the previous code. And now we'll come to this block actually. And what you can see here is we have two blocks, block named main read, another block named main write. Both of them have the same phase actually. The phase defined is, main. Again, the type is read for this particular block and the other one is write. We are writing parameters. Again, the ratio of two, basically we are going to run two statements from this read block while we run eight statements from this block. So we define the ratio, and this is typically to emulate the production environment. So you may have six writes happening to four reads, and basically that's the ratio. So if you have like 1 million transaction happening, they will actually distribute in the ratio that you define. So we're basically doing select or a read and select statement, and while we are continuing to insert. So let's go back and look at how this will look like. And again, for the purposes of this video, I'm using the standard out driver to show you how data will get generated from NoSQL bench and how it will hit your Cassandra cluster. However, you would want to use the SQL driver and make sure that you use the same kind of statement that I had shown in the PDF. So let's just run this and see how this looks. Main phase, let's run 100 statements. Again, std out, and let's see how that looks. So this should generate data. So if you see, we are having a read, we're having another read, but we're having more inserts going on. So that's what is essentially the overall objective of the test. Now, the key thing, if you've noticed here, is that you can define the way you want to do your design of the YAML file, but the meat of the bones is basically in the binding, right? The way you define your bindings, and bindings can be complex. So I want to give you a few examples that I have used in the past that you can look at, that you can use to create your, production like workload. So we'll have a look at that more advanced binding video, and then, I'll let you experience NoSQL Bench's awesomeness. All right. So the key to having a good load test is to have a good test with good quality data getting generated. Now, this data needs to emulate the kind of data that your application is getting generated and that gets loaded into Cassandra. So the key to doing that is through making sure that you're using the right bindings on top of your workload. So bindings basically help you generate the data, and it's using the virtual data set capabilities to generate all these. So there are various bindings available. If you come to the documentation, there are lots of documentation available around date functions, general functions, and state functions collections. Lots of values and lots of functions available. But in this video, I'm going to give you like some basic high level bindings that you can use to generate realistic data, similar to what you may have in production. All right, so let's just go into the bindings.yaml file and have a look at some bindings that can be used for creating production level data. So here what we have is different bindings available, and I'm going to output these out, and we'll see how they get generated and how this data looks. So let's start with partition ID. And typically what you would say is you want to create a partition in Cassandra. So you want to have repeated patterns, right? You want to have, 100 partitions, 200 partitions, 300 partitions. So you want to repeat the same set of users or transaction IDs or UUIDs. So what we can do here is we have partition ID, and I'm using something called mod that will allow that repeated pattern. So we are saying mod of 5 and then hash whatever is getting generated and convert it into a string. And then we have a separate ID that I'm generating through this function called weighted strings. And in that I'm saying the string that I want to generate for that ID is David, and the ratio is 1. All right. And So now we have S1 and we are generating only partition ID and ID. So let's have a look at how this works. And what you would notice is that mod will generate a similar set of patterns. So we wanted to generate five specific partition ID. So if you see 1, 2, 3, 4 and 5, and then the same pattern gets repeated. So basically this way we are generating different partitions, and now we have the same ID because the weighted string that we defined was 1. So the ratio was repeat the same thing again and again. We can go and change this up a little bit more by adding something called weighted string and breaking up that ratio. So we can break the ratio up. Now we are saying I want to generate New York zero point 0.5, Dallas 0.25, and Houston 0.25. This basically breaking the weighted strings uh, ratio up. Location, and let's have a look at this. We'll run this again, and this time you would see different pattern getting generated for the partition and based on the ratio that we defined. So as you said, New York was supposed to be higher because we said half of it should be New York. So, right, so let's go back. And now we want to generate another set of transaction ID. And again, what we're doing here is like generating an identity, and that's basically any number, and then hashing it and adding that to string. Before I run the next one, I want to talk about time bucket. Now, bucketing is a very important feature and kind of something that comes up a lot during Cassandra discussions, because you want to break your partitions sometimes and you don't want to have white partitions. So what we are doing to really what we want is we want to generate, in this particular example, I am creating bucketing based on year actually. But before we get to that, we want to get through some steps. So what we are doing here is we're using a weighted string and we are generating different timestamps, and these actually associate with different timestamps. We are converting this string now into a long, and then adding a hash range. A hash range is basically a specific time window that we are adding to this bucket, and then we are saving this as a specific time called tx time using save long, and then we are converting this by adding a string date wrapper into just the year format and saving that as a long in the output. But what you would see in the next part is date modified is basically calling this text time that is getting generated. So if here we were able to save a timestamp, that timestamp is getting saved, and that's what we are loading into our next function, and then we are converting that into to date, and that is what will get generated. So if you notice in our outputs, time bucket in the form of year, that's what is happening. And then we have the modified date getting generated. So if you noticed here, we had a date in this format, and we extracted only the year out of it, and that is becoming a part of our window. So that's another way to generate data, generate timestamp. All right, so let's go back in. You may also want to do a scenario where you want to create a pattern of names. So you can use a combination function, or you could also use uh, a function or generate a template. So you could generate something like template, add to curly brackets here, and basically pull in the various functions that you want to call in that. You can call any function in it. So you can actually have a last name along with a first name along with actually let's say identity. And as you can see, what we did was we kind of created a combination of words that run together and generate data together. So we have first name getting generated. Along with that, we had last name, but we changed it to identity. So it's generating identity function that gets generated in a sequence starting from 1. All right, so let's go back again. And now this is something that is very important. So I have come across situations where you would have 100 or 200 words that you want to get generated in a random way. So what you could do is just create a text file, and we'll see that text file, but call that text file in the form hashed line to string, and this will basically randomly take one input from the text file and generate that data. So here, if you can notice, what you have we have is, it label is a set of basically a set, or a list. So what I'm doing here is I'm saying I want a hash range between 3 and 5. So I want to create different sets, and each of these sets should have different last names. So you can remove the function that you want in it to an identity, or a different function like a weighted string, or a combination, or a mod, whatever you generate. But the key is that you want to use set and make sure that it's part of the set. And balance is basically we are generating a random number between 0 and, in this case, actually 100,000, and converting that to too long, so that it's basically a bigger number. So let's call these three functions and see how the output looks. And again, it's simple. The goal is to generate data that is realistic. So get to know your pattern. So if you see here, what is happening is it's generating randomly in this particular column, different numbers. And I will show you what the text file looks like, because this is data getting pulled in from a different text file. And again, we're generating a set. And if you noticed here, the size of the set is varying, because we've said we want the set range to be between 3 and 10. So it will change according to that, but it will generate different names, which is what we want the set to have based on the set range that we have put, or hash range. And again, we are converting into too long, but the last function was generating a balance, basically a balance amount. So this is what you can typically do. Again, I wanted to talk to you about that file. So let's have a look at the data.txt file. And if you come here, I'm just creating different patterns. Let's just go in again and just say, I want B1s, I want B2s, B3s, or B4s, and just save it. And every time we'll run the workload, it'll generate different numbers from that file. So let's just change this. Let's just make this, 15, and see what's happening. So this time, what you would notice is we will have 5 partitions. Each of them will have, think about it as like 3 records, because the same partition gets repeated. So same partitions, a set of partitions, and same set of partitions. But if you notice now is that we have, other data getting generated in the form of, B4, because we just added that capability in that data.txt file. So the key thing is you have the flexibility. Here, I use the std out driver just to showcase the fact that you can get the data generated in this form, but make sure that you are using the SQL driver, and you can create the schema in the schema phase, add a key, create key space, create table, add your custom index or the SAI index that you want to create, and then basically it's all about the bindings. So hope this was useful, and looking forward to any other questions that you may have, but the goal was to get you started. Again, please feel free to reach out to us. We're here to help you out. Thank you so much. Have a nice day.